Hello, good morning, one and all. So today we will start our lecture. Okay. So am I audible here? So please reply in the chat box. So am I audible? Okay. Yes, I am audible. Before starting our lecture, just I want to tell you some important instructions. So previous I have created one Google Drive. Okay. For ISC paper and again tutorial answer sheets. So there you have pasted your answer sheets. Okay. But what happened after some days, I checked all the folders, okay, and you have uploaded all your answer sheets there. But after that, again, after 4 days, again I have checked that Google Drive, but your answer sheets were not there. Okay, someone has deleted the answer sheets. So for this reason, I have created Google Forms now. Okay, almost 8 days or 10 days back, I have shared all the links of the Google Forms so that easily you are going to upload your answer sheets. Okay. But what I observed that many of you have not uploaded the your answer sheets on the Google form. Okay. So on the daily basis, I am checking that Google form, the responses I am getting there, but many students are not uploading the answer sheets. Why? Because I don't know. Okay. So on this platform, I am requesting you that so those who have not uploaded all the tutorials, means the total 7 tutorials we have conducted and one ISC. And suppose it means that you have not uploaded your answer sheets there, then you have to reappear for the tutorial and again for the ISC paper. Okay, indicates that only. You have written your answer sheet, you have not uploaded on the Google form, then it indicates that you are absent for the ISC. Okay. Today I am going to submit the marks of the ISC 1. I will check the papers those who have uploaded on the Google form here. Okay. Those who will not upload the answer sheets, then they have to appear for the re-ISC 1. Okay. That we have to remind this. So you all have to take care of uploading the answer sheets on the Google form only. And I'm getting the messages, sir, we have uploaded on the Google Drive. Okay, I told you that what is the problem in the Google Drive. So that is why I have created the Google Forms now. You have to upload on the Google Forms only. See the clearly one Excel sheet I have prepared, and in that Excel sheet I have given the link for each and every tutorial and again the IAC. The separately we need to upload it. Okay, and I think the many of you have uploading the answer sheet using the only one a link here. Okay, that is the not case. You have to upload the ISC one for the ISC Google form, and we have to upload the tutorial one for the tutorial one Google form. Okay, like that I have shared the total 8 Google forms. Okay, 7 for tutorials and 1 for ISC. And after this lecture, you have to take care that you have need to check those who have not uploaded the answer sheets. Again, I am requesting you that you please upload the answer sheet there. Okay. and those who will not upload the answer sheet, then they will be treated as the absenteeism. So the your marks will be the absent only. Okay. So that this is my humble request to you all. Please take care note of this one. So now we will come to our syllabus point. So till now we have conducted the total 16 sessions. Okay, 16 sessions means we have completed the 32 lectures. Okay, so near about 40 and again 42 lectures total we need to conduct, and the two chapters we have remained, chapter number 7 and again chapter number 8. So today we will start our chapter number 7, and after finishing the chapter number 7 we will go for the chapter number 8, and 7 tutorials we have conducted out of 9, so that the two tutorials we will conduct after this lecture. Okay, now we will start our chapter number 7. So I am going to share my screen here. Those who are having the any doubt, any problem regarding uploading the answer sheets on the Google form, so personally you send me the message. Okay, personally you can send me the any text message, so that immediately I'm going to give the reply to you. And one thing is that you have to log in by using the only college email ID. Okay, then and then only you are allowed to upload the answer sheets. Don't use your personal email IDs. Okay, so it doesn't allow you to upload the answer sheet on Google form. So for that purpose only you have to use the college email ID, and those who have not got the college email ID, so that you can approach to your CCs, so that they will provide you the college email IDs. So many questions I have got for this only. The many reasons I have got. Sir, we are uploading the Google form answer sheet, but it is not allowing you. Okay. What is the reason for that? You have to log in by using the only acquire the answer sheets. Okay. Now we will start our chapter number 7. And again, so the second ISC time we are going to conduct, do the study of the section second also. Yeah, here is. So I think you all are getting my. Are you getting the screen here? Are you getting the screen? Okay, yes. So this is the all chapters are there. The names of the chapters I have listed here. Uh, the first of all, the object-oriented modeling and design in the section 1 and again in the section 2. So in the section 1, the unit number 1 introduction, unit number 2 object modeling, unit number 3 dynamic and functional modeling, unit number 4 methodology preview and analysis, and section 2 unit number 5 behavioral modeling using UML, unit number 6 architectural modeling using UML, unit number 7 implementation of OMT, and unit number 8 design patterns 1. Okay, now we are going to start the unit number 7, the implementation of OMT. So this chapter is very easy like the previous one. So the easy concepts are there. So we'll see the syllabus points of this one. So the syllabus point of this one, the chapter number 7 is the implementation of OMT. So why the name is given as the implementation of OMT here? See, whatever the points we have covered, whatever the chapters we have covered in the earlier sessions, so by taking the help of all the chapters, okay, whatever the points we have covered, so by using that points, so now we are going to implement the such examples, okay, the such problems we are going to implement in this chapter here. So that is why it is called as the implementation of OMT. OMT means object modeling techniques here. Okay. So what are the syllabus points here? The syllabus points are very easy here. Okay. We all are familiar with all these points here. Nothing new in this chapter, but we need to revise it so that we will get the understandings of the implementation of OMT here. Okay. So the first point is about the use of programming language and database system. The next one, object oriented style and feature of object oriented languages. So the applications of OMT like first one, object diagram compiler, second, computer animation, and the last point is about the case study of first one, hotel management system, and the second one, course management system. So all these points we are going to cover in the chapter number 7, that is about implementation of OMT here. Now the textbook. So the textbook is about the object oriented modeling and design by Rambach, Pemerlani, A.D. Lawrenson, PHI publication. In this book it is listed, and it is for the course objective is about the 6. So the course objective is devise the real world problem using object oriented modeling techniques here. Okay. So this is the syllabus, and these are the required textbooks are available. Okay. Now the introduction. So what we are going to cover in this chapter, so that we will see in the introduction point. So once again, I want to tell you that so whatever the points, whatever the chapters we have covered earlier, so with the help of all these chapters, now here we are going to implement some problems. Okay. And the implementation of OMT means it is not like that we are going to write the code here. Okay. So writing code is an extension of the design process. Okay, the whatever we are going to write the code, it is the extension of the design process. Means clearly the 100% we need to design the problem. Okay, so after that only we are going to write the code here. The writing code should be the straightforward, almost mechanical, because all the difficult decisions should already have been made during the design here. Means in the design part only we need to analyze the problem, we need to find out some possible solutions. Okay, 100% work is for the design process only. And the code should be a simple translation of the design decisions. See, the very important point, the code should be a simple translation of the design decisions into the peculiarities of a particular language. Okay, means almost all our work is completed in the design process only. So there itself only we have written that which language you are going to use, what are the objects, how you are going to write the code, all the things that is listed into the design process here, not in the part of the code here. In the code part only we need to write into the programming language. Okay. Decisions do decisions do have to be made while writing code, but each one should affect only a small part of the program so they can be changed easily. But nevertheless, the program code is the ultimate embodiment of the solution to the problem. So the way in which it is written is important for maintainability and extensibility. A very important point. So nevertheless, the program code is the ultimate embodiment of the solution to the problem. So the way in which it is written is important for maintainability and extensibility. So implementation using a programming language. So friends, we know about the different programming languages are available. So basically here we are going to consider the only thing is that about object oriented languages. So all these object oriented languages we are going to consider here. So the most executable languages are capable of expressing the three aspects of software specification. Okay. The first one is the data structure. The second one is dynamic flow of control, and the third one is a functional transformation. Okay. The data structure is about so what the data we require, and the dynamic flow of control means how the programming is going to execute, and the functional transformation means so how the data we are going to transfer from the one location to the other location. Okay, that is called as the functional transformation. See, the data structure is expressed in a declarative, the non-procedural subset of a language. So whatever the data we are going to consider in the integer form, in the character form, okay, and the statements that are used to declare data structures are sometimes mixed in with the procedural statements, but are not executable. Okay. We know that the data structures that are not executables, and in some languages such as Ada, a sharp distinction is made between external specification, which is purely declarative, and the internal specification, which is often combined with a procedural statements here. And the flow of control may be expressed either procedurally conditionals, loops and calls, or non-procedurally rules, constraints, tables, and state machines here. Okay. And the traditional languages are purely procedural. Traditional languages means C language is a traditional language. Okay, means we are going to consider the procedure oriented language here. So the traditional languages are purely procedural, although the programmer can implement non-procedural constructs as data here. And the non-procedural languages, means our object-oriented languages, okay, such as rule-based systems, constraints, maintenance system, and logic programming languages support entirely different ways of organizing programs. Their relationship to object-oriented concepts is still under exploration. And support of Its support for concurrent threads of control is lacking in most major languages except for Ada. So the Ada is the one previous ancient language we used to use, like Pascal, Ada. Okay, but nowadays we are not going to use the Ada language. Multitasking and interprocess communication are provided by modern operating systems, but must be accessed from programs using occurred subroutine calls. Concurrency can also be simulated within programs using coroutines, control modules, or event handlers. Functional transformations are expressed in terms of the primitive operators of the language as well as calls to subprograms. And most procedural languages are similar in the kinds of functionality they support and do not differ greatly from Fortran. Fortran is also one procedure-oriented language. Lisp is also one procedure-oriented language. Lisp permits constructions of functions at runtime, which permits interesting and confusing operations. And the implementation of an object-oriented design is easiest using an object-oriented language, but even object-oriented languages vary in their degree of support for object-oriented concepts. Okay, and each language represents a compromise among conceptual power, efficiency, and compatibility with previous work. Even when a non-object oriented language must be used, an object oriented design is beneficial. So here you can give the stress on that. The object oriented design and object oriented language are most important. Okay. And object oriented concepts can be mapped into non object oriented language constructs. So there is really not a problem of power. After all, programming languages are eventually converted to machine language anyway, as much as an issue of expressiveness. So use of a non-object oriented language requires greater care and discipline to preserve the object oriented structure of the program, and the programmer cannot obtain help from the language in finding violations. So any language, object oriented or non-object oriented, is a tool that can be used well or poorly. Object oriented programming can greatly improve the expressiveness of programs, but it can also increase the opportunity for obfuscation by careless programmers. As with any craft, good programming requires discipline and adherence to principles of good style. So the writing code is also the important. So we must know the thorough knowledge about the object-oriented languages. So easily you can write the statements there. So that's why it is as with any craft, good programming requires discipline and adherence to principles of a good style. Now the second point is about the implementation using a database system. So friends, we know about the database system. So where you are going to store the large database there. Not it is for only for storing the database. So we need to access the database. Accessing the database also it is a very important. Okay. Nowadays in the computer era, so for a second we are going to generate the huge amount of data here, so that all the data we need to store for future purpose. So the implementation using a database a system here. So what is the point this one? So when the main concern is access to persistent data, rather than the operations on the data. A database is often the appropriate form of implementation. The main focus of a database is the structure and constraints on the data. So that I told you that the main focus of a database is the structure, how you are going to store the database. Okay, that is important. If you are going, it is the store the database well, then and then only it is possible to have the index on that. So database commands typically operate on sets of data from the database, incorporating a high degree of parallelism, while most conventional languages are highly serial. So database operations are much less procedural than conventional programming language statements, although they are more procedural than a rule-based system. Okay, and database provides concurrent operations on data by different users as part of their fundamental structure. Concurrent operations means suppose there is only one database is available, and for that many users can log in or they can access a database simultaneously. Okay. At the same time, they are able to access the database. That is called as the database provide concurrent operations on data by different users as part of their fundamental structure. Okay. Most RDBMS. So RDBMS means what? So the relational database management system. What is the RDBMS? It provides separate languages for data declarations and operations, analogous to the distinction in programming languages. And the DDL, so the DDL is nothing but the data definition language. So the data definition language means we are writing the code for accessing the database. Okay, that is called as the DDL. So the DDL is used to declare structure of data. A query language may be provided which allows the expression of functional transformations, record locking and update, and flow of control. So we know that the SQL language. So the SQL language is called as the query language. So by using the SQL language, you are going to access the database here. Okay. And the query language may be limited to simple record access based on fields that act as keys, or it might offer more of the features of a general purpose programming language. Some recent object-oriented database systems attempt to integrate an object-oriented language with a database in a single seamless package. And operations may be defined for each class of an object, but the programmer need not explicitly read and write information to persistent storage. Although object-oriented database systems promise better performance and easier use in the long run, they are not yet as mature as conventional relational database systems and may also pose problems integrating with existing conventional applications. Okay, this is about the implementation using a database system here. Now the object oriented style. So what is the style of the object oriented? So already we are familiar about this object oriented style here. So the good programs do more than simply satisfy their functional requirements. And the programs that follow proper design guidelines are more likely to be correct, reusable, extensible, and quickly debugged. Most style guidelines that are intended for conventional programs also apply to object-oriented programs. In addition, facilities such as inheritance are peculiar to object-oriented languages and require new guidelines. And we present object-oriented style guidelines under the following categories, although many guidelines contribute to more than one category. The reusability. The reusability means we can extend the code of the program. The extensibility means again we can update the program. The robustness, the correctness of the program should be achieved, and the programming in the large context of the programming we need to consider. So the reusability, again and again we can use the same code, that is called as the reusability. So the reusable software reduces design, coding and testing cost by amortizing effort over several designs. So what is the advantage of the reusability here? So advantage of the reusability is that reusable software reduces the design, the coding and testing cost by amortizing effort over several designs. Okay, and reducing the amount of code also simplifies understanding, which increases the likelihood that the code is correct. Reuse is possible in conventional languages, okay, but object-oriented languages greatly enhance the possibility of code reuse. And the kinds of the reusability, style rules for reusability, and using inheritance. So what is the kinds of reusability here? There are two kinds of the reuse. There are two kinds of the reuse. The first one is the sharing of newly written code within a project, and the second one is about reuse of previously written code on new projects. Okay. The first one is the sharing of newly written code within a project, and the second one is the reuse of previously written code on new projects. So the similar guidelines apply to both kinds of reuse. Sharing of code within a project is a matter of discovering redundant code sequences in the design and using programming language facilities such as procedures or methods to share their implementation. And this kind of code sharing almost always pays off immediately by producing smaller programs, faster debugging, and faster iteration of the design. And planning for future reuse takes more foresight and represents an investment. It is unlikely that a class in isolation will be used for multiple projects, and programmers are more likely to reuse carefully thought out subsystems such as abstract data types, graphics packages, and numerical analysis libraries. So the style second point is style rules for reusability. So how you are going to use the reusability. So there are different rules are available. So the first rule is about the keep methods coherent. Okay. Keep the methods coherent. A method is coherent if it performs a single function or group of closely related functions. If it does two or more unrelated things, break it apart into smaller methods. Okay, that is called as the keep methods coherent. The second, keep methods small. What is the meaning of the keep method small means? If a method is large, break it into smaller methods. A method that exceeds one or two pages is probably too large. So what is the size of the method? A method that exceeds one or two pages is probably too large. And by breaking a method into smaller parts, you may be able to reuse some parts even when the entire method is not reusable. And the keep methods consistent. Similar methods should use the same names, conditions, argument, order data types, return value, and error conditions. It maintains parallel structure when possible. The Unix operating system offers many examples of inconsistent functions. For example, in the C library, there are two inconsistent functions to output strings, puts and fputs. The puts function writes a string to the standard output followed by a new line character. Fputs writes a string to a specified file without a new line character. Avoid this kind of inconsistency. The second point is about the style rules of for reusability. It's separate policy and implementation. The policy methods make decisions, shuffle arguments, and gather global context. The policy methods switch control among implementation methods. Policy methods should check for status and errors. They should not directly perform calculations or implement complex algorithms. Policy methods are often highly application dependent, but they are simple to write and easy to understand. Policy methods are the mortar. Implementation methods perform specific detailed operations without deciding whether or why to do them. If implementation methods can encounter errors, They should only return status, not take action. And the implementation methods perform specific computations on fully specified arguments and often contain complicated algorithms. Implementation methods do not access global context, make decisions, contain defaults, or switch how of control because implementation methods are self-contained algorithms or self implementation methods do not access global context, make decisions, contain defaults, or switch how of control. Because implementation methods are self-contained algorithms, they are likely to be meaningful and reusable in the context. Implementation methods are the bricks. And it do not combine policy and implementation in a single method. Isolate the core of the algorithm into a distinct, fully specified implementation method. And this requires abstracting out the particular parameters of the policy method as arguments in a call to the implementation method. For example, a method to scale a window by a factor of 2 is a policy method. It should set the target scale factor for the window and call on an implementation method that scales the window by an arbitrary scale factor. Later, if you decide to change the default scale factor to another value such as 1.5, you just have to modify the parameter in the policy method without changing the implementation method which actually does the work. So it provides uniform coverage. If input conditions can occur in various combinations, write methods for all combinations, not just the ones that you currently need. For example, if you write a method to get the last element of a list, also write one to get the first element. Broaden the method as much as possible. Try to generalize argument types, preconditions, and constraints, assumptions about how the method works, and the context in which the method operates. Take meaningful actions on empty values, extreme values, and out of bounds values. Often, a method can be made more general with a slight increase in code. Avoid global information. Minimize external references. Referring to a global object imposes required context on the use of a method. Often, the information can be passed in as an argument. Otherwise, store global information as part of the target object so that other methods can access it uniformly. So the style rules of reusability, avoid modes. So we'll see that what is the modes are there. So the functions that drastically change behavior depending on current context are harder to reuse, and try to replace them with modeless functions. For example, a text processing application requires insert and replace operations. One approach is to set a mode to insert or replace, then use a write operation to insert or replace text depending on the current mode. A modeless approach uses two operations. First one is the insert and the second one is the replace that do the same operations without a mode setting. The danger of modes is that an object left in a mode in one part of an application can affect an operation applied later in the application. So using inheritance, so the preceding guidelines improve the chance of inheriting shared code, but sometimes, however, methods on different classes are similar, but not similar enough to represent with a single inherited method. There are several techniques of breaking up methods to inherit some code. The subroutines. The simplest approach is to factor out the common code into a single method that is called by each method. The common method can be assigned to an ancestor class. This is effectively a subroutine call and is shown in figure 1. That is, the common method is there and the method 1 A is there and again the method B is there. So this is figure for code reuse via subroutines. And the factoring means what? So the factoring is that in some cases the best way to increase code reuse between similar classes is to factor out the differences between the methods of different classes, leaving the remainder of the code as a shared method. So this approach is effective when the differences between methods are small and the similarities are great. So as shown in figure 2, the code reuse via factoring. So the method A to M and again method B to M. The common method, common code, call operation M, common code. So the common portion of two methods is made into a new method. The new method calls an operation that is implemented by a different method containing the code differences in each subclass. Okay. And sometimes an abstract class must be added to hold the top level method, and this approach makes it easier to add new subclasses because only the difference could need to be written. Now using the inheritance, a package for plotting numerical data provides a good illustration of factoring. Second, the data graph is an abstract class that organizes common data and operations for its subclasses. And the third one is one of data graph's methods is draw, consisting of the following steps. First one is the draw border, second scale data, third one draw axis, fourth one plot data, fifth one draw title, and again the draw legend. Next, using inheritance, the subclasses of data graph such as line graph, bar graph, and scatter graph draw borders, titles, and legends The same way but differ in the way they scale data, draw access and plot data here. But each subclass inherits the methods of draw border, draw title, and draw legend from abstract class data graph, but each subclass defines its own methods for scale data, draw access, and plot data. Friends, don't put the your attendance and roll numbers. Once I will tell you that, so at that time only you put your attendance. Okay, don't write your roll numbers here now. Okay, I am not going to record your present in right now. Okay, and each subclass inherits the methods draw border, draw title, and draw legend from abstract class data graph, but each subclass defines its own methods for scale data, draw access, and plot data. The method draw need only be defined once on class data inherited by each subclass. So each time the draw method is invoked, it applies draw border, draw title, and draw legend inherited from the superclass and scale data, draw axis, and plot data supplied by the subclass for the object. To add a new subclass, only the three specialized methods need to be written. So the first one is about the delegation. What is the delegation? So sometimes it appears that use of inheritance would increase code reuse within a program when a true superclass or subclass relationship does not exist. Okay, and do not give into the temptation to use this implement inheritance. Use delegation instead. Inheritance should only be used when the generalization relationship is semantically valid. Inheritance means that each instance of subclass truly is an instance of the superclass. Thus, all operations and attributes of the superclass must uniformly applied to the subclass. Improper use of inheritance leads to programmer that hard to maintain and extend. So very clearly we need to implement the inheritance, otherwise it leads to programmer that hard to maintain and extend further. Object-oriented languages are permissive in their use of inheritance and will not enforce the good programming practice that we recommend. So delegation provides a proper mechanism to achieve the desired code reuse. The operation is caught in the desired class and forwarded to another class for actual execution. Since each operation must be explicitly forwarded, unexpected side effects are less likely to occur. The names of operations in the catching class may differ from those in the class supplying the operations, and each class should choose names which are most appropriate for its purposes. So encapsulate external code. So often you will want to reuse code that may have been developed for an application with different interfacing conventions. So rather than inserting a direct call to the external code, it is safer to encapsulate its behavior within an operation or a class. This way the external routine or package can be changed or replaced, and you will only have to change your code in one place. For example, you may have a numerical analysis application, but knowing that reliable matrix inversion software already exists, you do not want to re-implement the algorithm in your object-oriented language. A matrix class might be written to encapsulate the functionality provided by the external subroutine package. The matrix class would have, for example, an inverse operation that takes the tolerance for singularity as an argument and returns a new matrix that is the inverse of the operation's target. Okay. So don't put your attendance, don't leave the Google room. Okay, just we will take the 2 minutes break here and again we will continue the lecture. So don't leave the room, don't put the attendance. Okay, we'll take the 2 minutes break only and again we'll start our lecture. So welcome once again. So we'll start the remaining point. So don't put your attendance again and again. I am telling, but many of the students are putting the attendance in the text box. So once again, I will make the request to you all. In morning there was very less attendance was there. Now 41 attendees are there. So I have created the Google Forms. So I request you all please upload your answer sheets in the Google Forms only using the Google Form link. So the Google Form link I have shared through the email. So you refer my email and you have to upload your answer sheets on the Google Forms only. So don't upload the answer sheet in the Google Drive. Okay. So because the I don't know who have deleted the answer sheets from the Google Drive. I requested them only you need to upload the answer sheet. Okay. That very easy work was there, but unfortunately that work was not happened. So that is why I have created the Google Forms there. So if you are having any problems for uploading the answer sheet, you please send me the personal message so that I can reply you immediately. Okay. Now we'll see our point using the inheritance. So encapsulate external code. So I think we have covered this slide. So we'll see the next slide. So the third point is about the extensibility. So what is the extensibility? So the most software is extended in the ways that its original developers may not expect. The guidelines for reusability enhance extensibility as well. In addition, the following object-oriented principles enhance extensibility. So it encapsulates classes. A class is encapsulated if its internal structure is hidden from other classes. Only only methods on the class should access its implementation, and many compilers are smart enough to optimize operations into direct access to the implementation, but the programmer should not respect the information in other classes by never reaching inside the class for data, and it hides the data structure. Do not export data structures from a method. Internal data structures are specific to a method's algorithm. If you export them, you limit flexibility to change the algorithm later on. And it avoids the traversing multiple links or methods. A method should have limited knowledge of an object model, and a method must be able to traverse links to obtain its neighbors and must be able to call operations on them, but it should not traverse a second link from the neighbor to a third class because the second link is not directly visible to it. Instead, call an operation on neighbor object to traverse the operation. Okay. If the association network changes, the operation method can be rewritten without changing call. Similarly, avoid applying a second operation to the result of an operation call unless the class of the result is already known as an attribute, argument or neighbor or the result class to perform the combined operation itself. The principles in this paragraph were proposed in the Lever 1989 as the law of the Demeter. So the third is about the robustness. Fourth one is about the robustness. So what is the meaning of the robustness? to try to guard against programming bugs as well as possible and give good diagnostic information even if fatal bugs occur. During development, it is often worthwhile to insert internal assertions into the code to uncover bugs, even though the checks will be removed for efficiency in the production version. A strongly typed object-oriented language provides greater protection against type mismatches, but assertions can be manually inserted in any language. Optimize after the program runs. Don't optimize a program until you get it working. Often programmers spend too much effort trying to improve portions of code that are infrequently executed. Measure the performance within the program before optimizing it. You may be surprised to find that most parts consume little of the total time. Study your application to learn what measures are important, such as worst case times and operation frequencies. And if an operation may be implemented in more than one way, assess the trade-offs of the alternatives as they relate to memory, speed, and simplicity of implementation. In general, avoid optimizing more of the program than you have to, as optimization compromises extensibility, reusability, and understandability. If methods are properly encapsulated, they can be replaced with optimized versions without affecting the rest of the program. And validate arguments. External operations, those available to users of the class, must rigorously check their arguments to prevent failure, but internal methods may assume their arguments are valid for efficiency reasons. Public methods must take more care to check the validity of arguments because external users are more likely to violate restrictions on arguments. Internal or private methods can often assume preconditions since the implementer has tighter control over the output. Public methods may assume validity because external users are more likely to violate restrictions on arguments. So the public methods must take more care to check the validity of arguments because external users are more likely to violate restrictions on arguments. Internal or private methods can often assume preconditions since the implementer has tighter control and can rely on the public methods that call them for error checking. Okay. Don't include arguments that cannot be validated. For example, the infamous scanf function in Unix reads a line of input into an internal buffer without checking the size of the buffer. This loophole has been exploited to write virus programs that force a buffer overflow in system software that did not validate its arguments. Don't write or use operations whose arguments can't be validated. And avoid predefined limits. When possible, use dynamic memory allocation to create data structures that do not have predefined limits. During design, it is difficult to predict the maximum capacity expected of data structures in an application, so don't set any limits. The fixed limits on symbol table entries, usernames, file names, compiler entries, and other things should be longer over. Most object-oriented languages have excellent dynamic memory allocation facilities. Instrument the program for debugging and performance monitoring, just as a hardware circuit designer instruments an IC board with test points. You should instrument your code for debugging, statistics, and performance. And the level of debugging that you must build into your code for debugging statistics and performance. The level of debugging that you must build into your debugging that you must build into your code depends on the programming environment presented by the language. And in Smalltalk, the Smalltalk is also one language. For example, a class browser allows a developer to explore the class hierarchy, displaying attributes and code for methods. An inspector lets the user interrupt execution and print the internal state of an instance. And if your implementation language does not have similar capabilities, then you can provide print methods for each class. And these methods can be accessed from also you can add debug statements to the methods. These debug statements are conditionally executed depending on an instance variable that contains the debug level. You can print a message on entry or exit and selectively print input or output values. Adding code to gather statistics will help you understand the behavior of your classes. Some operating systems such as Unix and VMS offer tools to create execution profiles of an application. Typically, these tools report the number of times each method was called and the amount of processor time spent in each method. If your system does not have comparable tools, you can instrument your code for gathering statistics much like for debugging. And programming in the large. So the programming in the large refers to writing large complex programs with teams of programmers. Human communication becomes paramount on such projects and requires proper software engineering practices, the following guidelines should be observed. Do not prematurely begin programming. It is important to first complete the generic thought process before confronting the quick of an implementation target. All software development methodologies emphasize the importance of first designing, then coding. Keep methods understandable. A method is understandable if someone other than the creator of the method can understand the code as well as the creator after a time lapse. Keeping methods small and coherent helps to accomplish this. Okay. And make the methods readable. So the meaningful variable names increase readability. Typing a few extra characters is cheaper than the misunderstanding that can come later when another programmer tries to decipher your valuable names. Check the readability of your methods by running them through a spelling checker. Avoid abbreviations that may confuse other programmers. Use temporary variables instead of deeply nested expressions. Do not use the two different purposes within a method, even if their usage does is cheap anyway. Use exactly the names as in the object model. The choice of names used within a produce additional name for implementation reasons, and this is fine, but the uniformity of names where they carry forward should be preserved. This practice improves traceability, document, and understandability for the software as whole. And choose names carefully while writing the code. Make sure your names accurately describe the operations, classes, and attributes they label it. Follow a uniform pattern in making of names. For example, you might use the pattern verb object in making up operation names such as add element or draw highlight. Be sure to define the verbs being used frequently. For example, you want to distinguish between copy and deep copy or between new and create. Many object-oriented languages automatically build method names from the class and the operation. Do not use the same operation name for semantically different operations. All classes that use the same name should have the same origin class and the same signature, number and types of arguments. So good, bad, circle area, matrix invert, performs matrix inversion, rectangle area, figure invert, turns figures upside down. So use programming guidelines. So project teams should use programming guidelines available in their organizations. If guidelines do not exist, the software team should create guidelines that address issues such as the form of variable names, indentation style for control structures, method documentation, headers, and inline documentation. Package into modules, group classes with similar functions into a module. First one is the module classes, plotting, line plot, bar chart, pie chart, geometry, polygon, circle, windows, menus, buttons, toggles, panels, animation, scenes, cues, keyframes. The document classes and methods. The documentation of a method describes its purpose, function, context, inputs and outputs, as well as any assumptions and preconditions about the state of the object. You should describe the algorithm, including why it was chosen. Internal comments within the method should describe major steps. Publish the specification. The specification is a contract between the producer and the consumer of the class. Once a specification is written, the producer cannot break the contract. For doing so would affect the consumer. The specification only contains declarations. So just 2 minutes. Don't put your attention. Don't put your attendance. Please don't leave the class. Okay. So the document classes and methods. The documentation of a method describes its purpose, function, context, inputs, and outputs, as well as any assumptions and preconditions about the state of the object. Okay. You should describe the algorithm, including why it was chosen. Internal comments within the method should describe measure steps and publish the specification. The specification is a contract between the producer and the consumer of the class. Once a specification is written, the producer cannot break the contract. For doing so would affect the consumer. The specification only contains declarations. The user of a method should be able to use the method just by looking at the specification. Some languages such as Ada and C++ support separation of specification and implementation. So online descriptions of the class and its features help promote the correct use of the class. So each operation should also be documented by itself apart from its method on each class, giving its origin, generic meaning, telling what each subclass must do to implement the operation, and what related methods are needed by the subclass. So here you can see one example for the class description, how you are going to describe the class. So the class description is the class name circle version 1.0 description ellipse whose major and minor axes are equal, superclasses ellipse features public attributes, center point location of its center, radius real its radius, public methods draw window draws a circle in the window, insert intersect a line, set of points finds the intersection of a line and a circle, returns set of 0 to 2 points, and area function, it's a real calculates area of circle, perimeter real, it calculates circumference of circle, private methods none. And this is about the, now we are going to see the method description. So the method description is that method circle intersect line set up the points description, given a circle and a line finds the intersection, returns a set of 0 to 2 intersection points, and if the line is tangent to the circle, the set contains a single point. Inputs self circle to be intersected with line, the line to be intersected with circle, returns a set of intersection points. Set may contain 0, 1 or 2 points. Side effects none. Errors if the figures do not intersect, returns an empty set. If the line is tangent to the circle, returns the tangent point. If the circle's radius is 0, returns a single point if the point is on the line. Now this is the operation description. So the operation description is that operation intersect line, the set of points, origin class, geometric figure. Description is it returns a set of intersection points between the object and the line. The set may contain 0, 1 or more points. Each tangent point only appears once. If the line is collinear with a line segment in the figure, only the two endpoints of the segment are included. Status abstract operation in the origin class must be overridden. Inputs self geometric figure to be intersected with line, the line to line to be intersected with the circle. It returns a set of intersection points. set may contain 0 or more points, and the side effects is the none. The errors, if the figures do not intersect, returns an empty set. If the line is collinear with a line segment in the figure, the set includes only the endpoints of the segment. If the figure is an area, then its boundary is used. Okay. This is about the operation description, method description, and again the class description. Okay. So this is the point we have covered from the chapter number 7. The remaining points we will see in the afternoon lecture at 1 p.m. So the meanwhile, I will give the tutorial question. So in the chat box, I will paste the tutorial question. Okay. So you all refer this tutorial number 8. I think we are going to cover in the today's. So it is the draw component diagram for the online examination system. This is about the tutorial number 8. So you need to upload this tutorial on the Google form. Okay, don't put the attendance. Okay, so I am getting the confusion while marking your attendance. Again and again you are going to write your attendance here, then it will create the problem. It will create the confusion to me. Okay, now this is the tutorial number 8. Draw the component diagram for online examination system. Okay, the component diagram we covered in the previous chapter. So the component diagram is the very easy one. So you have to draw the component diagram for online examination system. So you have to upload the tutorial on the Google Forms. So remaining student, you all, I request you that you please upload your all the answer sheet on the Google Forms only. Okay. So now only you can see the only once you have to put your attendance. Okay. Don't repeatedly you put your attendance, because it is going to confuse, it is going to create the confusion. So only once you put your attendance. So if anything problem is there about the tutorial or anything, just personally you can send me the message so that immediately I can give the response to you.